to the phase B and C. P is 3, V phase, I phase, cosine theta. So just multiply by 3. Q is the same thing, 3, V phase, I phase, sine theta. Now for single phase, we don't write phase and phase because it's only one phase. We don't have to write phase and phase. We don't have line to line or anything. It's just phase. What we have is phase. One phase only. Power factor is the same thing as the ratio between P and S. Is this okay so far? So 3-phase is just a single phase multiplied by 3. But we write phase here to show you because some people might get confused. There is a line and phase values. Now what I'm gonna do here, I'm gonna see S for Y connection and for delta. And this is, by the way, just go back here. This is just S cosine theta, right? Because this is basically S. And this is S sine theta. Because this is basically just S, the apparent power. And there is one more, that S is actually equals S squared equals to B squared plus Q squared. And this is because they make triangle. This is P, this is Q, right triangle, and this is S, and this is the angle theta. Now in in Y, what if we want to use V line and I line instead of phase and phase? So S will equal to 3. We're gonna replace V phase with something and V line with something, I phase with something. I phase equals I line. But what's the relationship between phase and V line? V phase here, let me just write it one more time. 3 V phase, I phase. So this is this, they're equal. Now phase in the line is V line divided by square root of 3. We're only taking the magnitude. So we're only taking the magnitude here. Remember, in the power calculation, we plug the magnitude here, not the angles, the magnitude. This is the RMS value, the magnitude. So if we simplify this, 3 divided by square root of 3 will give me S equals to square root of 3 V line, I line. So if I want to use the phase values, I multiply by 3. If I want to use the line values, I multiply by square root of 3. Here 3 divided by square root of 3 is the square root of 3 V line, I line. Now what if I have delta connection? S, again, always 3 times V phase, I phase. Now if I want to replace them, 3 V phase, I want to replace it, and I phase, I want to replace them with the line. Here V phase is V line. I phase is I line divided by square root of 3. From here, the magnitude only. The magnitude only. I phase is I line divided by square root of 3. So I can say 3 divided by square root of 3 is square root of 3. V line, I line. So what does that mean? if it's y or delta, it's the same thing. It's going to be s square root of 3 v line I line, s square root of 3 v line I line, or 3 v phase I phase. V phase I phase gives you the power per phase. If you multiply it by 3, it's going to be 3 phase power. Any questions? Okay. Now, there are, or before that, let's just go to the lecture, then we will. Okay, we're gonna go to the lecture and we will try to do 12 slides today. These first 2 slides are actually nothing, but. So 3-phase power measurement. We're gonna calculate the power and measure it. This is what we're gonna do here. So those are the single phase values. Okay, the average power, which is the real power, the reactive power, the apparent power. Now complex power is the complex number, P plus JQ. Remember, we are using the RMS values. No angles here. Don't plug here. It says this value, if the voltage is 20 angle 5, you only take the 20. Okay. If the current is 15 or 5 angle, let's say, let's make this 10 easier to calculate. And this is, for example, minus 20. We only take 5. Then the angle is the difference, 10 minus minus 20, 30 degree. Okay. The RMS value cosine, this is the angle between these two guys, which is 10 minus minus 20. Okay. Same here, same here, same. When we find P and Q, we can find this one. Is this okay? Because this is the common thing. People say, okay, I squared R is the power. I give them the current 5 angle 20. They come here and 5 angle 20. No, power doesn't have just the magnitude. And if the resistance is 2, then you just plug 2, then this is 50 watt. You never hear anyone saying it's 50 watt angle 20. No, the voltage, the current, the impedance they have, but the real power, apparent power, reactive power, no. Complex power, yes. It's called complex power because it's a complex number. The only thing, and even when we calculate it from these two guys. So keep in mind, we're using RMS values here, the magnitudes. Now, when we go 3-phase, we're gonna multiply by 3. Or, as I explained, this equals to actually this. Because in Y connection, V phase will equal V line divided by square root of 3. And delta connection, I phase will equal to V I line divided by square root of 3. So what will happen when I plug the line values for either delta or Y, I'm going to actually divide by square root of 3. So those are the active, reactive, apparent power, okay? If you have the phase values, you multiply by 3. If you have the line values, you multiply by square root of 3. Here's an example. They give you complex power, 12 and plus J15. What does that mean? complex power, we said it's P plus JQ. So the first number is P, the second number is Q. So from here, P is 15, P is 12 kilowatt, Q is 15 because the unit is kilovolt ampere here. The voltage is 240. Okay. First thing, it says, what is the magnitude of the line current? Okay. Now we can find S, the apparent power. And we know that S equals to the square root of V line, I line. So if I have S and I have V line given to me, I can find I line. And this is what we have here. Then it says the load is Y connected and the impedance of each phase consists of R and X. Find R and X. Okay. So what we have if the load is connected Y. Here, the load is R and X, each phase. We calculated the current. We know the line current here. We know the line voltage. You give me the line voltage and I know the line current. So the current coming here is 79.22. Current going this way, the line current. Because it's Y, the phase current is the same. And I know P, okay, per phase is a 12 kilowatt. Here we know per phase P equals to I squared R. I have I have P, I can find R, this resistance. And I know Q per phase is given to me 12 kilovolt ampere reactive and equals to I squared X. I have I and I have Q, I can find X, just rearrange. So keep in mind, P in a three phase equals to 3 V I cosine angle. Now those are phase values. Or 3 under the square root V line, I line, cosine the same angle in the previous one. Or if you have the current, it's current squared times the resistance. If resistance per phase, you're gonna multiply by 3. Okay. This is the three-phase power. If the one per phase, power per phase is just this divided by 3, P divided by 3. If you want Q, 3, phase voltage, phase current, sine the angle. Or if you have the line values, it's square root of 3. V line, I line, sine the angle. Or if you have the current and the reactance, it's 3 I squared the phase current. Phase current times X per phase. If Q is positive, now P is always positive. Q can be positive, can be negative. So if it's positive, we call it inductive Q. If it's negative, it means capacitive. If you want Q per phase, just it's a Q divided by 3, because we have only balanced system. We're only doing balanced systems. Again, another topic that you would need to practice in practice. Okay, another topic you need to practice. Now here's an exercise or example. This is a Y-connected load. They said find the average power P, reactive power Q, apparent power S. Now you find it the way you want. You have to find the current. You have to find the current, because in every formula, P, for example, is phase current, line current, or phase current. Okay, they all have current. So it's either V phase, I phase times 3 cosine, or V line, I line times square root of 3 cosine, or 3 I squared R. So always you need the current, one of the currents at least. Now this is a Y-connected load. So the line current is going to be the same as the phase current. So what did they give me? They give me the line voltage, this value here, the line voltage between line and line. I can find the phase voltage, which is just V line divided by square root of 3. In Y connection, V line equals V phase multiplied by square root of 3. So this is how we find the phase voltage. E line, which is the 200, divided by square root of 3. Someone would say, why we're not using the angles here? The only thing that we don't use the angle because we don't need them. But in reality, if someone says find the current, so we're gonna find the magnitude and the angle. Okay, so, but here I only need the magnitude. So if I find the V phase, I divide it by Z phase, I'm gonna find the I phase. Now what is the Z phase? Is this one, which is 3 plus J4, which is another way, 5 angle 53.1. So they only used the magnitude here, 5. The angle, they did not use it. If you use the angle, that's okay. So if you put here the angle, 36.8 or something. Oh, it's actually the other way around. It's 4 plus 3J. Why the angle is not right? It's the 4 plus 3J. So the angle is actually 36.9. If you use the angle, that's fine. If you don't use it, in this case, it's okay, because we don't need it. Then we can do this and this and this and find the values. Once you find the phase current, which is the phase voltage divided by the phase impedance, you can find the phase current. Then you can multiply it by the resistance, square it multiplied by resistance, you get the real power. You square it, you multiply it by reactance, you get the reactive power. So this is one example here. Here's another one. Now it's delta. Now in delta connection, V phase equals to V line. What we have here, we have the line voltage, 220 volt. We have the phase, the impedance, 10 plus J10 ohm. So we can actually say impedance per phase. If I change it, it will be 14.14. If you change it to polar, you don't have to. Okay, you don't have to. And angle 45. Oh. Now what I want to find the phase current, which is the phase voltage divided by the phase impedance. From here, phase voltage, because it's delta, is the same value. So 220 divided by 10 plus J10. And I only want the magnitude. Can anyone give me the answer for this? $15.6. Okay. Now it has an angle, but it's not important because I'm doing the power calculation. Now if it says find the current, you have to find it with the angle. But now I'm only finding the current to use it. It's not in my question. Okay, so the teacher is not gonna come and mark the current with the angle, they mark what you need for the power. Now, the power is, you can use either one of way, 3V phase, I phase, yes, fine. You can use I squared R, that's fine. So I'm gonna use the I squared R, it's the easiest here because I know the resistance. And I have 3 R's, 3 phases, so I'm gonna, each one of them will have this current. So it's 3 times 15.6 squared multiplied by R, which is 10. Then Q, question says the real power, reactive power, complex power, and power factor. Q3 I squared X, gonna be 3, 15.6 squared. X is 10 as well, happens to be the same. Then the complex S says complex power is P plus JQ. Then I'm gonna find the apparent power, which is the root square of P squared plus Q squared, the right triangle. Then power factor is P over S. Now the power factor is gonna be 0.707. And here, because it's inductive, it's gonna be lagging. These ones here, let me see, 220 divided by, if we square it, and if we square that one will be 200. Square of this is 200. So it's 220 divided by 200. That is like 22 divided by 20. So it's 11 over 10 times 220. Something like 240 here, I think. I'm doing it mentally. No, more than that. More than that. Because you have to multiply it by 10 and 3. Okay, how much is this? 6,000 something? 7,000? Any answers? Do it. Someone has to do it. I'm not moving on until you guys give me the answer. Three times 15.6 squared times 10. How difficult this is. Is this question difficult? Finding the phase current is the phase voltage divided by the phase impedance. Okay, phase current is the phase voltage divided by the phase impedance. In delta connection, the line voltage equals to the phase voltage. They give you the line voltage between here and here. It is the same as the voltage between here and here. This is the phase. Take the line voltage, which is the phase voltage, you divide it by the phase impedance, you get the phase current. Current, if you multiply it by current going here, it's going to be the same magnitude going like here, the same magnitude here. If you take the current squared, multiply it by the resistance, gives you the power here. Plus the power here, plus the power here, which is 3 times of the one of them, it'll give you the total power. I don't think this is difficult. Any question here? Any question? Okay. Now, that is how we calculate power. How can we actually measure the power? Okay, how can we measure the power? Now, one of the ways is to use 3 watt meters. So every phase, you're gonna connect 1 watt meter. Remember, when we connect the watt meter, okay, you have single phase. You want to measure the power, you're gonna connect your watt meter. Okay, this is the single phase. How do you connect your watt meter? You're gonna connect, I'm gonna need more space for this. So there's not gonna work, maybe here. This is, you want to connect your watt meter to measure the power here. So what you do, you bring your watt meter. The watt meter measures the voltage and measures the current. So the way it measures the current, like an ammeter exactly. So you would do it like this, you insert it in the circuit. This is a meter. Voltmeter, when you do it, you connect here and the other one to measure here. This is a watt meter. It has two coils. One coil to measure the current, one coil is to measure the voltage. To know the power, you have to know about the voltage and you have to know the current. Okay, and this is per phase, so it's just phase voltage, phase current, okay, and cosine the angle between them. Once they measure, the wattmeter measures the current and the voltage, it will find the angle between them. So this is single phase. We do it for the three phase. This is 1 wattmeter. This is another wattmeter. This is a third wattmeter. Every wattmeter is going to measure the phase voltage and the phase current, and will give you one reading. Okay, so let's say that we have three phase like this. The Y connected. That is not enough there. This is one phase. Okay, you're gonna connect your wattmeter. So you're gonna bring first wattmeter. We'll measure the current. Then we will measure the voltage. Okay. Then you do the second wattmeter is the same thing. This is the second phase. So the second wattmeter will be connected to the second phase. We'll measure the current. And we'll measure the voltage, 1 point here. And 1 point will go from here to the neutral, so cross. Then you do it for the third one, like this. So this is the coil that measures the current. This is the coil that measures the voltage. Okay. Make sure you have the same polarity. So if positive is here for the voltage, should be for the current, but should be positive here for the voltage. Okay. Three phase. Now, if you have delta connection, you're gonna take each one of them. This is the voltmeter of the wattmeter, and this is the ammeter of the wattmeter. Okay. So these are the two coils here. This is how you connect them to measure the power. Each one of them will measure one phase. Each one of them will measure one phase. Now, in a case that it's not Y or delta, you don't even know what it is. So load is like that and has three terminals. This is how you connect them. So you go ammeter, voltmeter, ammeter, voltmeter, ammeter, voltmeter. This is one device called wattmeter, okay? One device called wattmeter. Here's an exercise here, and we'll show you. It says, okay, for this network, we're gonna use the 3 wattmeter technique. It means 1 wattmeter per phase. Sketch the connection required to measure the total power to the load using 3 wattmeters. When I do this, I'm gonna redraw the thing. Okay, so I'm gonna redraw the thing. So this is my connection. This is the neutral. If you don't have a neutral, then you connect the ones all together. Now let's look how can we connect the wattmeters. First wattmeter, current coil, a voltage coil. The second wattmeter, current coil, a voltage coil. A third wattmeter. Just gonna use the space so we can have current coil and a voltage coil. So current is connected like this. This is the current coil. to measure the current. So positive, negative. Voltage, positive, negative. It's gonna connect across the phase. So this coil is called the voltage coil, potential coil. And this is the current coil. Okay. This is gonna measure the current going to the phase A and the voltage cross phase A between here and the neutral. The second one, this is the current and this is the voltage. Positive here, positive here. Sorry. This is for the current and this is for the voltage. Okay. So this is gonna measure the voltage, so it's potential coil, and this is gonna measure the current coil. Here's the same thing. This is measuring the current, positive, negative, as the current is going this way, and the voltage between here and the neutral. So the phase is positive. The one that's connected to this is negative to the neutral. This is how I connect the watt meters. This is watt meter 1. This is watt meter 2. This is watt meter 3. This is the watt meter. So 3 watt meters, each one of them will measure the power in one phase. Each one of them will measure the power in one phase. Okay. Now there is another way, like the lab connection. It's going to be like this. Okay. So I'm going to do the same circuit. Now I'm going to put my watt meters in another way. This is the watt meter, like in the lab. This is another watt meter. And this is the third watt meter. So this has current and voltage. Current and voltage. Current and voltage. So this is to measure the voltage, this is to measure the current, this is to measure the voltage, this is to measure the current, this is to measure the voltage, this is to measure the current. This is watt meter 1, this is the second watt meter, this is the third watt meter. So for measuring the current, it will be connected like this. Use different colors for connections. So like this. This one here is going to measure the phase current. And this is going to measure the phase current. The voltage, one is going to be connected here. It means different colors so we can see the voltage. So the positive is here, the negative is to the neutral. This one is the same. The positive is here, the negative is connected to the neutral. Same here, the positive is here, the negative is connected to the neutral. So this is how you connect the watt meters, the 3 watt meters, okay? Either with the coils, the shape of coils, or the shape of the ones that we have in the lab. So always make sure the polarity matches. What does that mean? Is positive here, current is positive here. Then this is negative, this is negative. Is connecting the 3-watt meters okay? There will be question in the final. Sketch the connection to measure the power using 3-watt meters. And maybe even in the lab test. Okay, now the other question says determine the total power, okay, which is the reading of each watt meter. Now, each watt meter is going to read 1/3 of the power. So, what is the power here? If I can find the current, it's I squared R. So, line voltage given 220. Phase voltage, because this is Y connection, it's V line divided by square root of 3. Then I can find phase current, which is the V phase divided by Z per phase. Then I can find P, which is 3, because 3 phase, I phase squared R. This is the procedure. 220 divided by square root of 3. So this gives me, how much is this? 127? Then 127 divided by 12 plus J16. The phase voltage divided by the phase impedance. Whatever give me here, I don't care about the angle. I'm just going to take the magnitude. Then I plug it here. This is the P. Now reading of each watt meter. Will equal to power per phase, which is whatever we have here, P divided by 3. This is the 3 phase. Anyone can give me the answer here? Six 6.35 ampere. So this is 3 times 6.35 squared times R, which is 12. Real power is only in the resistance. Then give you the answer here. You can plug it here. How to connect the watt meters is very important. Now there is another technique we're going to do next class, which is only using the 2-watt meters, only using 2-watt meters to measure the power. Now this is the 3-watt meter. Hopefully this is okay. Please review this one more time. Later, 3:30, there will be a tutorial in the lab, a tutorial in the lab. I will have maximum of 15 students. Maybe, I don't know how many will attend, but not so many people or lots of people actually don't even attend the regular class. So I'm assuming that they're not coming to the tutorial, hopefully. I don't want to see so many. I don't want to see so little as well. The number 10 to 15 students would be great. Any questions?
Sir, it will be on campus or online?
On campus. On campus. Midterm, I did not finish grading yet. I did not finish grading yet. There are 50 something students. It takes time to mark them, to mark the papers. Everyone can come to the campus, I believe. I think you can come to the campus. So let me do the attendance before you guys can go. Abdullah Abdulrazak. Muhammad Mohsen.
Yes.
Hassan Abu Hassan.